we've got a fellow kettle, gorgeous electric kettles.
And this is the kettle we got. Anyway, the lid has had a problem.
This just pops off, which shouldn't happen.
So we need to fix it.
We've got a crack in the wood. So the steam softened the wood and then it slid.
Split it.
So this has a crack in it. Well, either way, I think this is a perfect chance to kind of just take this.
Yeah, he thinks the new one's the fun projects. Yeah, we do too.
Just 3D model this real quick and then print it and then heat set it on. Because it's basically all the same technology.
Here, what?
Looks pretty good.
Here.
Oh, man.
We should actually start prepping the filament that we want to print with. So maybe we should decide what color we want to print the knob in.
Well, if we want to like make it close to wood, there's, let's see.
Well, we can't.
Crap.
Let's talk about material for a second. So I don't have ABS because it's fumy and I wouldn't want to be in the space while it's printing. I don't have ASA because of the similar problems. I mean, that leaves PLA, PETG, nylon, and polycarbonate. Those are the ones that I have. The one that might be the most durable
PETG, I think, yeah.
Might be the easiest to print would be PETG. And I do believe I've got some Signal White in PETG.
You do.
But there might be some other ones, and we definitely need to be drying PETG before we use it.
Okay, so we got PETG. Now we have PETG, Signal PETG. I'm going to put this in the dryer, yeah? Okay. It is drying.
All right, well, let's do some housekeeping. Let's try to get this threaded insert off. So there's the brass insert. So this is what we're treating. It's split. It was a piece of wood. The humidity from the electric kettle caused it to crack. This is what the new one looks like. It's an injection molded plastic, and it's still got the brass insert in there. The top is actually flat.
And on the wood, it's got a bow to it.
Yeah. The next thing that we're gonna do, so we got the filament drying.
Check.
We have to decide which one of these we're gonna model. Are we gonna model the wooden one, or are we gonna model the new plastic one? So which one do you want?
Well, I think we can do this size, but with this slope. That's the beauty of doing 3D modeling yourself.
Yeah, the other concession that we're gonna make in terms of modeling this has a bevel on the top. We're just gonna make it flat so that we can print it
like, yeah,
straight down on the
and usually the first layer is the prettiest.
Yeah, the first layer will be the prettiest. So I'm gonna move back to Autodesk Fusion and we're gonna draw a sketch. All right.
Oh, it looks great.
So
now we have basically a quarter view of it, right?
Yeah, so now we've got the sketch.
Okay.
So we can come up here to finish, and we're gonna come back and look at it from like the top angle again. Okay, let's see. Create, revolve. I think we can revolve. So we can revolve it.
Oh.
Look at
it showing us. It's like, hey, it might look like this.
Yeah, we're going to revolve it 360 degrees.
To object.
I can just do full. So operation new body, that makes sense. Project access. Yeah, that's good. Selected, we're good to go. That's what the object's going to look like. We realized that we don't need an inset hole. We're just going to, because the brass insert for this one
long
is bigger than the white one.
Yeah.
Okay, so here we go. We have to measure this, and with these brass inserts, there's some like little teeth or grooves. And we don't want to measure the outside of those because we want those to get into the plastic.
We want to do the inside of the grooves.
In between the grooves, there's a narrower part that is 5 millimeters. In between the grooves is 5 millimeters. I can even go a little bit smaller. So maybe I'll do like 4.9. And the depth of this one, 12
12.
millimeters. So, and we learned before that it's good to have a little extra space. So maybe we'll do 12 and a half.
Okay, 12 and a half.
Okay, so I got 2 edges selected now.
This.
We're doing a chamfer instead of a fillet because it's easier for the 3D printer to print chamfers.
It's a flat 45-degree angle.
So these are equidistant selected. We did 1/2 millimeter, which is fine. I think that
We know that 5 does not.
totally enough. So if you notice, the top and the bottom both have a tiny chamfer on them. All right, I just exported the 3D print file, and now I will go over to Prusa Slicer, and there's our knob. It's like literally right there. We have a couple settings that we're gonna do. First, we're gonna print this in 0.6 because, you know, why not? So now we're in PETG land. So the slicer now knows about PETG. We can zoom in now and we can look at these layers, and you can see a little bit how the chamfer has helped with those edges. One of the things that I'm going to do is we're going to change the top infill to concentric may look better than Archimedes chords on the top. So concentric is
might look nicer.
a bunch of concentric circles. So one ring inside of the other. On the top, we did Archimedes, and you can see it doesn't stop. So it'll be a little bit faster, but there might be
a little gap.
A little gap or blemish. I'll do concentric on both. I mean, I could also do like crazy designs. We could do like an octagram spiral, which is actually kind of pretty.
Oh, do that. That's beautiful. On the bottom? Do that on the bottom. It's very like we're quilting and crafting.
The next thing we're going to do is we're going to find a glue stick to prevent it from oversticking or understicking. So I've got the glue stick over here. And we need a wet paper towel. So now we're going to go back and we're going to slice it. We're going to finish our slicing. So the next thing to consider is what other settings do we want to run on the slicer? Right now, it says 15% infill, and it's our good old friend gyroid or droid. I don't know how to pronounce it right here. Now we could have different infill techniques if we want. We could have a higher density if we want. So putting this back up to...
I think we do 30. I think that's not a bad idea.
20 looks pretty good, but I think 30 is a good number because we want some weight and some density to this. It's not just about strength. So we can see how each layer is going to build inside of here, and that looks pretty good. Now the next thing that we're going to consider for this part is a little extra strength, and this is going to be with the layers. We probably want an extra top and some extra bottom layers, and we probably want some extra perimeters. So we've got a few extra perimeters here.
That's good because when I saw it before, you could see the infill on the curve.
And if you notice, the perimeter's only added a minute, but it's gonna add more strength than the infill will. All right, so let's talk about other considerations. We want that scarfing to happen. Scarf joint, place nowhere.
Everywhere.
Yeah, and this piece we're gonna observe a little bit more than normal. So I really want to put that scarfing in there. All right, so that looks good.
Yeah, we're gonna see it every day.
Only added a minute. Let's just check some of these other settings.
We're just changing the speed settings for a 3D printer so that we can start to get it going. It's right over here.
All right, we'll see if
it.
wrecks it. We saved like 3 minutes on this particular print.
It's so
it'll
tiny.
probably make the printer a little bit noisier. Now we're ready to export the G code. We're going to export it also in downloads for now. All right, so it just loaded. And this one's PETG, and it's Prusament, right? So we can see that it's preheated. It's ready to go. These, I can clear all of these. These are the raw commands that are coming into the printer. And you can see when I hit print, it's going to start going.
It's giving our printer over here all the information it needs.
So these are the actual literal G code commands.
All right, so we have on this side, that is our machined part that we got from the manufacturer, and this is ours. And honestly, I feel like it looks really good. So now I'm going to turn on
We're at 512 Fahrenheit.
the soldering iron, and we'll take the threaded heat insert and insert it into the hole.
I think I put a chamfer on the insert part of this before, so it would self-center a little bit. So that's in there now. We just got to wait for the plastic to cool. It's cooled down enough.
Okay, let's give it a try. Looks pretty good.
There.
Oh man.
Those of you joining us, it was great seeing everyone. Thank you.
Bye.